All right, so first thing we're going to do, we have lesson 1, geometry. We are reviewing some algebra 1 material, which is very, very important and relevant in the course of geometry. So today's main area of focus is slope, and we have a couple things that we need to know how to do. First thing that we're going to figure out how to do is how to find the slope of a line. And this is when you are given a graph. Then we're going to go over how to find the slope of a line through a pair of points. We are going to go over how to find the slope of each line given slope-intercept form or given a line that is not in slope-intercept form. And after we go over each type, we will do a couple examples and take some notes in this little block. And then you guys will have an assignment to do. So let's get this started. How to find the slope of a line. One thing that you need to know when you're finding the slope of a line is the word slope has an abbreviation in this class, and that abbreviation is a lowercase m. Lowercase m, excuse me, is what we use to represent slope in an equation. It is not including the x next to it. It is just the number in front of x. Sometimes a number or coefficient is invisible, in the sense that you don't need to write it, and that's typically a 1, or sometimes sort of like that -1 where you just see the negative. We don't normally write a positive sign, it's implied, right? Now, we also have a formula for slope. We have words for slope. We have a couple options. Some words that people use to define slope that's going to be a little helpful when you have a graph are rise over run. By rise, we mean if something moves up, then we use a positive number for our rise. And for our, we'll do a little colon. I don't want to do an arrow again. For the run, so rise up high, or we go down, then we would use a negative. These are just little things, positive and negative rules that really trip people up, okay? If it's down, we're going to use a negative. And the run, we can run to the right. So run, you run left or right. So if you go to the right, we count the number of boxes and we make it positive. And if we run to the left, we count the number of boxes and make it negative. So the last one was positive. This one is negative, okay? So if we're using visually rise and run, you need to know these facts, okay? You need to get those jotted down. Another thing that we can kind of make a little note of is positive over a positive is going to be the same slope as negative over a negative. I know this is like a weird little notation I'm writing over here, but if we see some examples in a few minutes, like +2 over +5, it's the same as -2 over -5. Question, Alex, what's up?
Could you go on present mode, because like all I see on your screen is like pretty small.
You have to pin my screen. Do you see the little push pin when you hover your mouse over my window?
Yeah, I got it.
You got it? Everyone else got it? So when we're presenting in the Google Meet, you have to pin my screen and it'll make it much, much bigger. Also, what helps is if you drag the window, it's a little weird with the ratios, but if you make your window wider or taller, sometimes that even helps you see more of the edge. I try to stay away from the perimeter for that reason, because sometimes it's a little funny, okay? If anyone else has an issue, just let me know, okay? So those are the same. And then if we have a positive over a negative, that's basically going to work out the same as a negative over a positive. And we will see that in another example. I know it looks like crazy little notation over here, and maybe I sound like a crazy person, but I will try to reference that in a little while. Those are little clouds of symbols, okay? Then the formula, though. What about a formula? Like, I want a formula, punch the numbers into this formula, figure it all out, and I want to be good to go. I don't want to use this abstract rise over run. Okay. The formula is, think about, it's called assonance when the inside of a word sounds like another word, like the inner vowels of a word sound alike. So rise goes with Y, it's up high, you know, So if that helps you remember. So the y's are going to go up top. These are what we call subscripts. Superscripts are the ones that go up in the exponents. So Superman, superscripts, they fly up high, and subscript, like a submarine, they're down low. Okay. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the way you figure out the run, we said, is left and right. Well, it's really asking you how far the x has changed. So to find change, we subtract. And then to find your rise, that's how much your y's changed. And to find change, we subtract. So even if you work on a cash register, the change is the difference. You get that with subtracting, okay? And this is going to be very helpful if you are given, or if you could extract from the picture, if you are given an ordered pair x1, y1, and another ordered pair x2 and y2. So remember, x comes first, alphabetical order. And I'm going to use given in quotes because it might not be explicitly given. Explicit means like in your face. It might be implicitly given or implied. So in this example down here, we have two examples. It's more implicit where it's implied the ordered pairs. And if you look very carefully, they even made 2 points, like bullet points, like bold, so that we could use those. Okay. So everyone should have written down slope. Here we're going to be given a graph. So visually from the graph, we can figure it out as a rise over run. I'm going to do this one maybe that way. I'll do both of them both ways so you have options. And then this one over here, I'm going to use the ordered pairs in the formula. Okay, so I'll do both of them. Hopefully we have all this down. And again, we have our options, rise over run and formula. So I'm going to scooch over here. If you need me to go back, I will go back in a minute. I'm going to zoom in a little bit more. There we go, and okay. If it's ever like too bright or too dark, let me know. And then I'll end this video after these two, and then I'll make 2 other little videos, so there'll be little snippets. And this way they'll be uploaded while you're working on the assignment, hopefully, and you could reference it if you need to. Find the slope of each line. So I'm going to write down, to help myself memorize, I'm going to write m equals, or maybe in front first, slope equals m equals rise over run. If you write it enough times, the first few times you do it, you will memorize it. Equals y2 minus y1 over x2 minus x1. Now, let's say we wanted to do rise over run. The 2 points, I know it might be hard to see here, but there's these bold dots right on the graph paper, right about there. What are the ordered pairs of those points? Anybody could figure out, or we could do rise and run. So actually I was going to do rise and run. So let me do that first. So I'm going to color coordinate for you. Rise. That's our, scooch back over here. We said that's our up or down. Rise. If we go up, we use a positive number. And if we go down, we use a negative. Now, if you're going to do the rise, run visual way of doing it, and some of you might think it's easier, you're just going to count some boxes, you need to pick 1 point to be your starting point and 1 to be your finishing point. I like to go from left to right, the way we write our name, the way we read. So I'm going to go from here to here. If I start here, how much do I rise? I know we're not rising if we go down, but you know, we use our imaginations here. So how many boxes, if you could count, 1, 2, 3. So what number should I write over here in this little yellow blob? Well, I said I went down for my rise. I didn't go up, I went down, and I went down 3. So I'm gonna go ahead, I'm gonna say m equals, so far I have -3 over, now it's time for the run, left and right. I always think run in the X direction, you might run from your X if you see them somewhere, like, oh no, I don't want to talk to them. So run, okay? If we go to the right from where we left off, we're going to use a positive, and if we move to the left, we're going to make it a negative. So from here, I'm right there is where I left off, and I'm going to go 1, 2, 3, 4, 5, and 6. So you really just want to make sure, because you have to show work, you better count real careful if you're doing the counting method, you know? So I just went to the right 6 boxes. So is that a positive 6? Is that a negative 6? If I went to the right, it's positive 6. Now, you might need to reduce. What number can I reduce from this numerator and this denominator? What number can I reduce? Or simplify? I can cross out the, anybody want to say?
3.
Nice. We're going to cross out the 3. Thank you. So the 3, adios, is gone. Crossed it out. Be careful, because sometimes people are like 3 and 6 division 2, negative 2. It's negative 1 over 2. So if you look, I kind of broke down the multiplication so I could see it a little bit better, and negative 1 over 2. So m equals negative 1 over 2. And I circle it. I showed my work. Amazing. Ooh, sorry. Amazing. Okay. That would be a lot of good work done. That would be acceptable. The other option is using the formula. So if you're going to use the formula method, so this was rise run, you have your options, okay? Maybe you want to switch it up. Maybe you do odds one way and you do your evens another way. You pick, okay? If I do the formula way, I need to write down what the ordered pairs are. And that's why I said you might be given ordered pairs. They're not like told to you, but we could figure them out. Can anybody tell what this ordered pair is right over here? If that's the origin? It's a negative x value and a positive y value. If you can't count, I'm going to tell you over here. If you can't see it, maybe you could have pulled this up on your Google Classroom PDF. Negative 1, negative 2, that's the x. And then the y is up 1, 2, 3, 4 from there. So negative 2, 4. And then here we have another ordered pair. I don't know if anybody wants to go for that one, but that's the origin. And that's 4 to the right and 1 up. Now, it doesn't matter which one you want to make, x1, y1, whatever, okay? It doesn't matter. What I'm going to do is, you know, I'm going to think like, okay, this time I'm going to call this x1, y1 on the right, because I kind of started here. I don't know, whatever. It doesn't matter. It's just switching it up, okay? Then that one will be x2 and y2. Ordered pairs should always be written in parentheses. So now if those are my ordered pairs right over there on my paper, and I want to plug those, I'm going to color coordinate again. I like to color coordinate all the time. There's one guy. That's my orange point right here. And my green highlighter is pretty dry, but I'll try to. That's that one there. So if you use the formula way, if you like a formula, you're a formula kind of person, all good. M equals, I write the formula, y2 minus y1. Remember, y goes up high. Y goes up high. Y2, that's going to be 4, minus y1 is 1, over, and I'm going to color this green and orange to match up there, okay? Minus, on bottom, x2 is negative 2, minus x1 is 4. Now, if you ride the struggle bus, when it comes to positives and negatives, you gotta speak up and we gotta resolve that issue, because it's only gonna get worse next year if you don't deal with it now, okay? So those are my numbers. I think the numerator is pretty easy. We have 4, take away 1. 4, take away 1, we get 3. As opposed to the negative 3. It's because we went the other way, so it'll all make sense in a second. Negative 2 and negative 4, they're the same sign. Same sign, find sum, keep same sign. My Algebra 1 teacher a million years ago made us sing and dance that. Same sign, find sum, keep same sign. So if they're both negative, just add the numbers. 2 plus 4 is 6. keep same sign. Make it negative. -6. This here is what I was talking about over here. Positive over negative, negative over positive, all the same, okay? Because here I could go rise 3, backwards run 6. Same idea. Rise 3, backward run 6, you know? But it still reduces to 1 over -2. But the thing is, in math, is we always try to move our negative out of our denominator up top or in front of the fraction bar. You might see it written like this, 1 over 2, and they stick the negative right there. I'm not a big fan because it starts to blend with that fraction bar, so I always make sure it's nice and clear up top. So I don't care, you pick. If you like this method more, use that method every time. Just really show that you're counting the boxes somehow. And if you like this method more, that might be a little bit better for you to show your work. All good. You shouldn't be busting out a calculator. You should kind of be doing it by yourself. Now, the second example, I'm only going to do one way for the video, for the model. Which way do you want me to model for you? Don't just pick the one that you think is easier. Maybe pick the one you think is harder. Which way? Rise, run, or formula? Anyone could pick. Whoever speaks first gets to decide. I picked formula. No one picked? That's all good. So origin's right there. If I go 1, 2, 3 units to the left to get to this point, right there, sorry. If I go 3 units to the left to get to that point, what's this ordered pair? Anybody know? I'm modeling it here. So if you get one on an axis later, make sure you look at this example, okay? It's going to be -3, comma, 0, because you don't move up or down. So the second number is 0, okay? Here, I move to the right from the origin. This is the origin where the X and Y axes cross. 1, 2, 3, 4. And then I go up 1, 2, 3. So that ordered pair is 4, comma, 3. Now I'm going to name one of them the 1 couple and the 2 couple, the sub 1 and sub 2. X1, Y1, and this one is X2, Y2. Formula, M equals Y goes up high in the sky. Y2 is 3. Maybe put a little tail on your Y because it starts to look like X's, you know? So I should do that myself. 3 minus 0. I will go back and color it in a minute. And then X2 minus X1. All right, minus -3. Minus -3. What happens? Do you guys know what happens when you have minus negative in a problem? What happens when we get minus negative? What does that turn into? Minus.
Doesn't turn to a positive.
Yes, good. 2 of you, thank you. Perfect. Good. So the way I used to remember, for anyone who maybe forgets, minus negative becomes plus. Like I imagine them moving in my head into literally a plus sign. Okay?
Excuse me?
Yes.
Do we have to do it this way, or could we just count rise over run?
That's what I told you. You guys could do it either way right now. It's fine, but you won't always have a graph. So in like the next set of examples, for these, when it's a graph, if you want to count, that's fine, okay? But here, do you see you don't have a picture?
Yeah.
So that's why I'm kind of going over this for practice, so we could kind of get that practice out of the way for that, you know?
So do we need to copy what you wrote down? Because I just wrote down the answer.
Well, if you're going to do so see here how I gave like some color or something, you need to somehow show work. So you need to just kind of show, I don't care if you grab like a color pen or a highlighter and kind of like mark up the paper a little bit too. When you do your actual assignment, I just need something to prove to me that you're not just, because I'm literally giving you guys the answer, Kate. Like it's going to give you the answers. You can't just write an answer because I gave you the answers, you know? Okay, so you have to show the work somehow. So if you're going to show it like this and just draw arrows and right? Like -3, +6 underneath the picture. That's something, okay? For all of them. But it's fine if you count it, okay? M equals 3 minus 0 is 3. 4 minus -3, we said becomes 4 plus 3. So that's 3/7 and nothing to reduce. If you wanted to plot points with that slope, you could use -3/7, but M equals 3/7 and you are golden. That's the end of that example, okay? You can write M or you can write slope, whatever you love, okay? So I'm going to end this recording here. If you understand this recording, you put thumbs up. If you're like, you're a crazy lady, what are you talking about? What is slope? Put a thumbs down so I can try to make a better explanation of this for next time.